Ethereum development has advanced a lot in the past few years, but we still have a little bit of flaws in the security model that it has. One of them, it's called fractured trust networks. It seems like a detail and something minor, but in the end of the day, it's really crucial for Ethereum's success. So let's talk a little bit about this issue and really understand how can we solve it. And this fractured trust networks problem really came from the beginnings of decentralization of blockchains, right? Each blockchain had to develop its own infrastructure in order to have a new functionality or a new app to play. The first one, Bitcoin, of course, only allowed for one use, which was peer-to-peer electronic cash system. So if you wanted to do something else, you would have to build your own blockchain. And that's what Ethereum did. But still, in Ethereum, every app that uses external sources, so any app that requires data or approvals that are not on chain, so things like weather or the result of a game or an oracle for a price index, or anything that really relies on external sources, it has to create its own trust network, which means that Ethereum security, which is considered to be very strong, is not transferred to this other app. So at the end of the day, what you have to do is to build your own trust network, which increases the difficulty and increases a lot of the resources that you have to spend in order to reach this mass adoption and this security that's ideal. So this issue really creates four drawbacks for the chain, and we'll be talking a little bit about each one of them. The first one is called Decentralization Overload, which basically means that every single new development or application needs to be its own trust network. We talked a little bit about this previously, and that's the first problem that arises from this. The second one is starting from scratch. So it basically means that for every app, it needs to deploy a lot of resources in order to increase the security and the adoption and to really reach the stage that it needs. The third one is called double dipping, which basically means that you're charging fees twice. One for the app, so for the use of the Oracle, for example, and one for the chain to pay for the gas transactions. And the last one, it's called the weakest link dilemma. So instead of you relying on Ethereum security, which is very robust, as we talked about, you rely on the weakest link, which means that if you have, let's say, use the Oracle example, and you have a new protocol that doesn't have many validators to check if the data is correct, if you're able to attack that failure point, that will be enough. So the Ethereum security and the robustness that it has is not transferred to this app, which creates this weak link dilemma. With recent developments, we've seen some interesting alternative solutions that could really improve this scenario. And one of them is called restaking. We'll talk a little bit about this later on, but next I wanted to touch on a concept that is called cost of corruption. I hope you've enjoyed this, and if you like this kind of content, don't forget to subscribe, like the video, and share with anyone who might be interested. So thank you so much.